Welcome back to JVM Internals Crashcasts. I'm your host, Shayla, and today we're diving into a fascinating topic, interpreter versus JIT compiler. We're currently in level 2 of our series, which focuses on operational understanding of the JVM. Victor, are you ready to explore this topic with our listeners?
Absolutely, Sheila. I'm excited to break down this crucial aspect of JVM performance. It's a great topic that bridges our previous discussions on memory management with the intricacies of how Java code actually runs on the JVM.
Perfect. Before we dive in, let's start with a quick quiz for our listeners. Here's the question. In a typical Java application, what percentage of code do you think is actually JIT-compiled? Is it closer to 10%, 50%, or 90%? Think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Sheila. It really makes you think about how the JVM operates under the hood. I'm sure our listeners will have varied guesses based on their experience. Let's keep them in suspense while we explore the topic.
Agreed. Now, to set the stage for our discussion, could you briefly explain what we mean by interpretation and compilation in the context of the JVM?
Certainly. In simple terms, interpretation is the process of reading and executing code, line by line, while compilation involves translating the entire code into machine language before execution. The JVM uses both of these approaches, which is what makes it so interesting.
That's a great starting point. So, how does the interpreter work within the JVM?
The interpreter in the JVM reads the Java bytecode and executes it instruction by instruction. It's like having a translator who's translating a foreign language to you in real time. This allows for quick startup times because the JVM can begin executing code immediately without any pre-processing.
I see. And how does this differ from the JIT compiler?
The JIT compiler, which stands for Just-in-Time Compiler, takes a different approach. Instead of interpreting each instruction, it compiles frequently used parts of the bytecode into native machine code. It's more like learning the foreign language yourself. It takes more upfront effort, but allows for faster communication in the long run.
That's a helpful analogy. So if the interpreter is quicker to start, why do we need the JIT compiler at all?
Great question. While the interpreter allows for quick startup, it's generally slower for long-running operations. The JIT compiler, on the other hand, can significantly improve performance for code that's executed frequently. It analyzes the code as it runs and optimizes the parts that are used most often.
I see. So it's a trade-off between immediate execution and long-term performance. How does the JVM decide when to use the JIT compiler?
The JVM uses a technique called adaptive optimization. It starts by interpreting everything, but it keeps track of how often each method is called. When a method is called frequently enough to cross a certain threshold, the JIT compiler kicks in and compiles that method to native code.
That's fascinating. It seems like the JVM is constantly analyzing and adapting its own performance. Are there any downsides to JIT compilation?
Yes, there are a few. The main one is that JIT compilation takes time and uses memory. This can lead to a brief pause in execution when compilation occurs, which is why you might notice a slight delay when you first perform a complex operation in a Java application. Also, the compiled code takes up more memory than the original bytecode.
I can see how that could be an issue in certain scenarios. Are there situations where one might prefer pure interpretation over JIT compilation?
Absolutely. In environments with limited memory or where consistent performance is more important than peak performance, interpretation might be preferred. This could include certain embedded systems or real-time applications where predictable timing is crucial.
That makes sense. Now, I've heard about something called warm-up time in relation to JIT compilation. Could you explain what that means?
Of course, warm-up time refers to the period when the JVM is gathering information about code execution and performing initial JIT compilations. During this time, the application might run slower than its peak performance. After the warm-up period, when frequently used code has been compiled, you'll see the best performance.
Interesting. So, for short-running programs, the warm-up time might actually negate the benefits of JIT compilation.
Exactly right, Sheila. For very short-lived programs, the interpreter might actually be faster overall because it doesn't have the overhead of compilation. This is why the JVM's adaptive approach is so clever. It can handle both short and long-running programs efficiently.
This has been incredibly informative, Victor. Before we wrap up, let's reveal the answer to our quiz question. Remember, we asked what percentage of code in a typical Java application is JIT-compiled. Victor, would you like to do the honors?
I'd be happy to. The answer might surprise many of our listeners. In a typical Java application, only about 10% of the code is actually JIT-compiled. The vast majority is still handled by the interpreter. This highlights how selective and efficient the JIT compiler needs to be to provide such significant performance improvements.
Wow, that is surprising. It really underscores the importance of understanding both interpretation and JIT compilation. To summarize our main points: 1. The JVM uses both an interpreter and a JIT compiler. 2. The interpreter allows for quick startup, while the JIT compiler optimizes frequently used code for better long-term performance. 3. The JVM uses adaptive optimization to decide when to compile code. 4. JIT compilation involves trade-offs in terms of memory usage and warm-up time. 5. Only a small percentage of code is typically JIT compiled, but it can have a big impact on performance. Thank you, Victor, for sharing your expertise with us today.
It's been my pleasure, Sheila. This topic really showcases the sophisticated engineering behind the JVM's performance.
Indeed, it does. In our next episode, we'll be diving deeper into tiered compilation, another fascinating aspect of JIT compilation. Don't miss it. And to our listeners, if you've enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of JVM internals. Until next time, happy coding.